This is the first videotape on solving word problems. Somehow setting up and solving verbal problems has become one of the most feared topics in algebra. Approached systematically, there's no reason for you to fear this topic, and there's no reason that you can't master it. The big difficulty is that you're given a problem in words, a problem in English, and you have to translate the English statements into algebraic statements, which will then give rise to, which are equations, which you will then solve. Now, solving the equations is not the difficult part. It's setting up the equations. Before we start with large problems and try to translate them into algebraic statements, let's start with simple phrases, okay, and work on translating them into algebra. Okay, let's start very simply with 5 more than x. Okay, 5 more than x, 5 more than a number x. You could say x plus 5. 5 more than x. Also, you could write 5 plus x. 5 more than x. I prefer the first representation over here. Although these are the same, x plus 5 equals 5 plus x, because addition is commutative, it's usually more convenient to put the variables first. Okay, so 5 more than x. If you like, you can think of it this way. 5 more than x, you can write 5 more than something and then put the x in afterwards. 5 more than x. Okay, a more than b. A more than b. A more than something, a more than b. B plus a. A more than something, a more than b. B plus a. Okay, 5 less than x. 5 less than x. That means 5 less than something. 5 less than x. X minus 5. Okay, here it would be incorrect. It's not 5 minus x. Okay, here you don't have a choice. 5 less than x. X minus 5. This is not the same thing. For example, if I say, what is 5 less than 11? Okay, forget about algebra. I say, what is 5 less than 11? You would all say 6. It's 11 minus 5, which is 6. 5 less than 11. That is 5 from 11, giving you 6. You wouldn't write 5 minus 11, which is minus 6. 5 less than 11, taking 5 away from 11. Okay, a less than b. We're taking a away from b. A less than b. B minus a. X less than 5. This is 5 minus x. We're taking x away from 5. Okay, here, 5 less than x. We are taking the 5 away from x. 5 less than x. 5 fewer than x. We take 5 away from x. Here, x less than 5. We take x away from 5. X fewer than 5. Okay, how about 7 more than twice a number? 7 more than twice a number. We can let some variable represent the number x, n. Let's let n equal the number. 7 more than twice a number. 7 more than twice a number. 2n plus 7. 7 more than twice a number, or twice a number. Okay, increased by 7. 7 more than twice a number. How about twice the sum of a number and 7? Twice the sum of a number and 7. Once again, let n equal the number. twice the sum of a number and 7. Twice the sum of a number and 7. 2 times, in parentheses, n plus 7. Here we have the sum of the number and 7, n plus 7. We want twice the sum of the number and 7. Okay, this is 2 times n plus 7 in parentheses. Before we had 7 more than twice a number. That was 2n. N was doubled, and then plus 7. 7 more than twice the number. Here, just n was double. It was twice the number, and then you added 7. Here, however, it's twice the sum. So first you add n and 7, and then twice that entire sum. So you need the parentheses to represent this statement in algebra. Okay, twice the product of a number and 7 more than the number. Twice the product of a number and 7 more than the number. Okay, we can let x equal the number here. We want twice the product of a number and 7 more than the number. Twice the product of a number and 7 more than the number. Okay, the number is x, and then 7 more than the number is x plus 7. 2 times twice. Here we have the product of a number and 7 more than the number. This is the number. This is 7 more than the number. Here is the number. Here is 7 more than the number. Okay, here is the product of a number and 7 more than the number. Okay, you don't really need the dot here for multiplication. You have the parentheses. The number, 7 more than the number, the product of the number and 7 more than the number, and then take twice that whole thing, twice the product. Okay, here the brackets are really unnecessary. You can just write this as 2x times x plus 7. Twice the product of a number and 7 more than the number. Okay, now let's move on and try to translate a whole sentence into algebra. And this is going to give us an equation, and we'll try to solve that equation. Six less than 3 times a number is 4 more than twice the number. Find the number. This is our first full-fledged word problem. Okay, all we're going to do is translate this phrase here, translate this phrase here. The is that we see here will be translated as an equal sign. While a phrase translates into an algebraic expression, a full English sentence like this is going to translate into an algebraic equation, which we will then solve for the unknown. Okay, words like is or yields or results in, things like that, generally translate into the equal sign. Okay, in this case, let x represent the number. You can use any variable, of course. Now, 6 less than 3 times a number. Let's just worry about that. 6 less than 3 times a number. 6 less, we're going to take 6 away from 3 times the number. 6 less than 3 times a number. I've translated this thing in here, this phrase here. That's over here. 6 less than 3 times a number. 6 less than 3 times the number is equals 4 more than twice the number. 4 more. We're adding 4 to twice the number. Okay, this phrase here translates into that. Okay, the squiggly phrase translates into this. The underlined phrase into the 2x plus 4. 6 less than 3 times the number is equals 4 more than twice the number. Okay, we have now a nice first-degree equation, one variable here, and we're going to solve for x, and that'll give us the number. Now to solve, we'd like to isolate x. Okay, let us subtract 2x from both sides. This gives us 3x minus 2x. X minus 6 equals 4, and then add 6 to both sides. X equals 10. The number is 10. This is our solution. Now, we want to check our answer. To check a word problem, you don't just go in, plug into the equation that you have here, because after all, this equation was something you translated the English statement into the algebraic equation. Suppose you made a mistake in translating. Most people, that's where they make the mistake, in translating the English into algebra, not necessarily in solving the algebra. So you go back to the words of the problem, okay? You look at the first phrase. You say 6 less than 3 times the number, and figure out what that is. Well, 3 times this number, that's 30. 6 less than that is 24. 6 less than 3 times a number. The number was 10. 3 times that was 30. 6 less than that, 24. On the other hand, we want 4 more than twice the number. Twice the number, that's 20. And 4 more also gives us 24. So we see that for this number, 6 less than 3 times the number comes out to be 24. That's exactly equal to 4 more than twice the number. So we've checked in the words of the problem. When I say consecutive integers, I mean the integers that come right after each other. Consecutive integers, integers that come one after the other. For example, 4, 5, and 6 are consecutive integers. Okay, now let's look at the relationship between consecutive integers. The difference between 4 and 5, there's a difference of 1 here, and also a difference of 1 here. 5 minus 4 is 1, 6 minus 5 is 1. That is consecutive integers. The integers are going up by 1. Okay, you could write them as 4, 4 plus 1, and 4 plus 2. The first one was 4, the second 4 plus 1, the third 4 plus 2. Either 1 more than the 4 plus 1, which gives us a 4 plus 2, or 2 more than the first. Okay, that's if your first integer was 4. Let's say you're starting with the first integer and you're going to represent it by x. And if you want to indicate, say, 3 consecutive integers, and the first one is x, and the second one would be x plus 1, and the third would be x plus 2. Okay, very often you're called on to work with consecutive integers. Okay, and you specify the first one is x, the second x plus 1, the third x plus 2, and so on if there's more than 3. Sometimes you're asked about consecutive even integers. And consecutive odd integers. Okay, examples of consecutive even integers would be 10, 12, and 14. Even numbers, of course, are evenly divisible by 2. When you divide by 2, there is no remainder. Consecutive even integers. The even integers that come right after another. Okay, now notice that there's an increase of 2 as you move from one even integer is the one right after it. 12 minus 10 is 2. 14 minus 12, that's 2. If you were to specify the first even integer in your sequence by x, the one after it would be x plus 2, and the one after that, x plus 4, to indicate that they're going up by 2, whereas the consecutive integers were going up by 1, 4, 4 plus 1, 4 plus 2, okay, or x, x plus 1, x plus 2. The consecutive even integers are going up by 2, 10, 12, 14, x, x plus 2, x plus 4. Examples of consecutive odd integers: 5, 7, 9. If you were to specify the first odd integer in a sequence by x, and the one after it would be x plus 2, the one after that, x plus 4. Now you might say, how come you can use the same 3 setup here, x, x plus 2, x plus 4, for even and for odd integers? Okay, the trick is that it all depends on what x is. If x is even, for example, if x is 10, then 10 plus 2, that's 12, and 10 plus 4, that's 14. If the first one is even, adding 2, you'll still be even. Adding 2 again, you'll still be even. On the other hand, if x is 5, add 2, you'll be odd. 5 plus 2 is 7. Add 4, you'll still be odd. So the whole thing is your starting point. If the problem has to do with even integers and you let x be the first of the even integers, then you can let x plus 2 and x plus 4 be the ones that come right after it, and it'll be all right, because if the first one is even, and these will be even as well. On the other hand, if the first one is odd, these will be odd as well. Let's try an example using the idea of consecutive odd integers, for example. The sum of 3 consecutive odd integers is 1 more than 4 times the smallest. Find the integers. Okay, we're dealing with consecutive odd integers, and we have 3 of them. As we mentioned over here, we're going to let the first one be x, the second one x plus 2, the third x plus 4. Let x be the first integer, x plus 2 the second, and x plus 4 the third. By the way, the first is also, in this case, the smallest. For example, 5, 7, and 9. 5 is the first, and it's also the smallest. X is the first integer. This is the first of the odd integers, the second and the third. Just to indicate that they're odd. They're going up by 2. The first odd integer, the second odd integer, the third odd integer. Okay, the sum of 3 consecutive odd integers is 1 more than 4 times the smallest. Let's translate that. The sum of the 3 consecutive odd integers. That's x, x plus 2, and x plus 4. The parentheses are not really necessary. I'm just putting them in for emphasis here. We're adding up 1, 2, and 3. The sum of the 3 consecutive odd integers. The result is 1 more than 4 times the smallest. 1 more than 4 times the smallest. 1 more than 4x. X is the smallest. It's the first, it's the smallest. The sum of the 3 consecutive odd integers is 1 more than 4 times the smallest. Okay, now let's see what we have on the left side. We have x, plus x plus 2 plus x plus 4. So we have x, x, and x, 3x plus 6 on the left equals 4x plus 1 on the right. We have x, x, and x for the 3x, 2 plus 4 for the 6. Okay, subtracting 3x from both sides. 6 is equal to x plus 1. Subtracting 1 from both sides. Five equals x. Okay, 5 is equal to x. Now let's see what we found. We have found x, the first of the odd integers. Over here we have found that x is equal to 5. Then x plus 2, 5, once we found x is 5, this is 5 plus 2, that's 7. This is 5 plus 4, that's 9. We have here 3 consecutive odd integers. Let's see if it satisfies the condition of the problem. Okay, we're going to check in the words of the problem. Okay, for our check, we want the sum of 3 consecutive odd integers to be 1 more than 4 times the smallest. The sum, it's 5 plus 7 plus 9, 21. 12 and 9, that's 21. 1 more than 4 times the smallest. 4 times the smallest is 4 times 5 and 1, that's 21. And it checks out. The sum, 5 plus 7 plus 9, 21, is equal to 1 more than 4 times the smallest, 21. Okay, so we have found 3 consecutive odd integers. They're 5, 7, and 9. Okay, if 2 numbers add up to 20, and one of the numbers is x, how do you represent the other one? In terms of x. This idea comes up a lot in verbal problems. Okay, and we are restricted, the problems we're solving, we're restricted to one variable. You can't say, well, I'll make one x and one y or something like that. We only have one variable. Okay, if 2 numbers add up to 20 and one of the numbers is x, how do you represent the other one in terms of x? Okay, anytime you're faced with an idea and you can't quite figure out how to work it out, try to work with numbers that you understand. Let's say one of the numbers, if one number is 8, and they add up to 20, what would be the other number? Okay, most people here would have no difficulty. If one number is 8, the other is 12. If one number is 8, the other is 12. You know that because you want them to add up to 20. So once you had the 8, you said 20 minus 8, and you figured out that was 12. On the other hand, if one is 17, the other is 3. Since 20 minus 17 is 3. Okay, the idea being you want to find out what's left over. Okay, you subtract what you have from 20, find out what's left over, and that gives you the other number. So if one number is x, the other is, okay, now when it was 8, you took 8 from 20. When it was 17, you took 17 from 20. When it's x, you take x from 20. This follows exactly the same pattern that we set up here. One was 8. To find the other, subtract the 8 from 20. 1 was 17. To find the other, subtract 17 from 20. 1 is x. To find the other, subtract x from 20. This is the only one, however, we can't simplify. I mean, we leave it as 20 minus x. And as a check, you have 8 and 12 add up to 20. 17 and 3 add up to 20. And x. And 20 minus x, the x's cancel, and they add up to 20. So if one number is x, the other is 20 minus x. And as I said, this idea is going to come up a lot in word problems. In fact, let's try one right now using this concept. If the sum of two numbers is 30, and 3 times the larger is 2 more than 8 times the smaller, find the numbers. If the sum of two numbers is 30, and 3 times the larger is 2 more than 8 times the smaller, find the numbers. Okay, we're starting with the sum of two numbers is 30. Then the other one must be 30 minus x. Remember, if two numbers add up to 20, we let one be x and one 20 minus x. Two numbers add up to 20. One is x, one is 20 minus x. If we want two numbers to add up to 30, one is x and one is 30 minus x. Okay, now, x is one of the numbers, 30 minus x is the other number. Now, if you look in the problem, they talk about one being larger and one being smaller. It doesn't matter how you do it as long as you're consistent. You specify one of these numbers as the smaller, the other one as the larger. Regardless of how you do it, as long as you're consistent all the way through, you will get the correct answers. Okay? Maybe your value of x will be different, okay, but the final answers will be exactly the same. Okay, so let's arbitrarily, let me say that x is the smaller number and the other one is the large number. I could have done it in reverse, but once I've specified it, that's it. Now, every time I talk about the smaller number, I use x. Every time I talk about the larger number, I use 30 minus x. You had a certain amount of leeway here. You could have specified it either way, but now that you've got it specified, that's it for the problem. Okay, we have already taken care of the sum of the two numbers is 30. This is built right in here. X and 30 minus x, if you add them up, that clearly is 30. 3 times the larger. 3 times the larger. 3 times 30 minus x. The larger is 30 minus x. 3 times the larger is, that's your equals, 2 more than 8 times the smaller. 2 more than 8 times the smaller. Here is our equation. Now, as I said before, the big thing is getting the equation. Most of you are going to be able to solve an equation like this without any difficulty. The big thing is just to get the equation from the English problem. If the sum of two numbers is 30, we specified x and 30 minus x, 3 times the larger, 3 times 30 minus x is or equals 2 more than 8 times the smaller. Now we have to solve this equation. Okay, let us distribute the 3 through the parentheses on the left. We get 3 times 30, that's 90, minus 3x is 8x plus 2. Let me finish it up here. 90 minus 3x is 8x plus 2. We can add 3x to both sides. 90 minus 3x and the plus 3x, that drops out, equals 11x plus 2. Now subtract 2 from both sides. 88 equals 11x. Divide both sides by 11. 11 into 88 goes 8 times. X equals 8. Okay, x is equal to 8. We have found x. That is the smaller number. Okay. X is 8. This is the smaller number. The larger number is 30 minus x. If x is 8, 30 minus 8 must be 22. Remember, the smaller and the larger together are supposed to add up to 30. We need two numbers which add up to 30. And now, the condition that we want to check, is it true that 3 times the larger is 2 more than 8 times the smaller? Is it true that 3 times the larger is 3 times 22, that's 66. 3 times the larger, is that 2 more than 8 times the smaller? 8 times the smaller, 8 times 8, that's 64, plus 2, this is also 66. Okay, so here is our check. The numbers do add up to 30, 8 and 22. 3 times the larger, 66, is equal to 2 more than 8 times the smaller, also 66. This brings us to the end of the first videotape on verbal problems. The next videotape on verbal problems will give you a chance to try some more problems and to get some more practice in setting up and solving word problems.